So now let's make an example. Look at that. Y second derivative minus 3y derivative equals t square. So this is non-homogeneous because there's a t square on the right hand side. So as a step 1, we are finding the complementary solution. So complementary solution, if the right hand side is 0, what is the solution for the left hand side? And you know that this is just constant coefficient, so we can solve it by using the characteristic equation. And characteristic equation for this y second derivative minus 3y is r square minus 3r equals 0. And if you factor out, you can find the roots as 0 and 3. And you can write the complementary solution as c1 e to the 0t, which is 1, plus c2 e to the 3t. So you already have the complementary solution. So as a second step, we are finding the particular solution. And to find the particular solution, we are using the table. So look at the gt. gt is just t squared, just a polynomial. So if you look at the table, for the first row, if gt is only a polynomial, and the trial form is t to the s, a and t, and nth order polynomial anyways. And we said that in here s is the multiplicity of 0. So look at that. This is my trial form here. I already copied from the table. And I am checking if 0 is coming as a root. Yes, it's coming once as a root. That's why I'm saying s is 1, because r1 is 0. And n is 2, because look at that. This is t to the n, right? Our power for our gt, t square, look at the t square, it's second order. That's why my n is 2. And if n is 2 in the trial form, look at that. If n is 2, it will be a2t to the 2 plus a1t plus a0. It will come. And my then particular solution will be t to the s is 1t, times n is, the nth order is the second order. So if I multiply by t for this polynomial, I will have a2t cubed, a1t square, a0t. And we need to take the derivatives, second and first derivative. The first derivative of this one, 3 times a2t square, 2a1t, a0. I am taking one more derivative, 6a2t plus 2a1. And now I need to plug in this inside my original equation here. And if I do that, look at it here, I plugged in, and y second derivative 6a2t plus 2a1 minus 3 times y prime, and since we already found the y prime, just plugged in that, make it equal to t squared. Look at that, only t squared term is minus 9a2, then it should be 1 because the coefficient of t squared is 1, so this has to be 1. Then a2 is minus 1 over 9. Look at the t terms, 6a2 and minus 6a1. It has to be 0 because there is no t term. That's why a1 is also equals a2, which is minus 1 over 9. Look at the constant terms, 2a1 and minus 3a0. From there I can find a0 is minus 2 over 27. So my solution is in the form of y complementary, y particular. Y complementary I found as c1, c2 e to the 3t from the first step. Here you go. And from the second step, particular solution was in the form of, here you go, this one. So I found what is a0, what is a1, what is a2, and I'm just plugged in inside, and this is the general solution of my non-homogeneous differential equation.